Before we talk about attacking SQL, let's quickly understand what SQL is. Structured query language is how web applications talk to their database. Think of a database as a locked filing cabinet, and SQL is a language the web application uses to ask the cabinet for information. Here's a simple example. A login form. The app takes your username and password and builds a query. Select everything from users where username equals admin and password equals admin. If that match what's on the database, login successful, admin access rights granted. Simple, predictable, and that predictability is exactly what attackers exploit. SQL injection happens when an attacker manipulates the query the apps sent to the database. Here's the key problem. The application expects a normal response, but instead, the attacker types in actual SQL code. The app doesn't check, it just blindly stuffs that input into the query, and the database can't tell the difference between data and code. So it just executes everything. That one flaw is enough to change the entire logic of the query and potentially let an attacker access, modify, or even delete data they were never supposed to touch. Classic injection. Let's make this real. Here is the actual payload. Watch the login form. Normally, the query looks like this. Username equals John. Password equals my password 123. Two conditions. Both have to be true. Now watch what happens when an attacker types that payload into the username field. Instead, the single quote closes the string the app opened. Then, or 1 equals to 1, which is always true, gets added to the query. And that double dash at the end comments out everything, including the password check. So the database literally never checks the password. It just sees through, match the first row in the table, usually an admin, and logs the attacker straight in. But before an attacker can do this, they need to find the vulnerability first. That's where the single quote comes in. It's the simplest test in SQL injection. You send a lone quote as an input, and if the app is vulnerable, it breaks. You see a database error pop. That's your signal. The door isn't locked. Once you get that error, you can build, add logic, add comments, even pull data using union statements. The quote is everything you need to break in. What you just saw is called inbound SQL injection or classic SQL injection because the attacker sees the results immediately right in the app response. That's actually the easiest type to exploit, but there are other two types of SQL injection you run into. Blind SQL injection, where nothing shows on the screen at all. So the attacker has to ask the database true or false questions and read the answer directly from how the app behaves. Maybe the page loads slower, maybe it responds differently. Out of one SQL injection, the rarest one, where the attacker can't see anything in the response. So they make the database send data through a complete separate channel like DNS, HTTP request to a server they control. We will get hands-on with all this in the future lab, but for now, just know these three types exist and how attackers can exploit them. So why does any of this matter outside a lab environment? Because SQL injection isn't theoretical. It causes some of the biggest breaches in history. If an app is vulnerable, an attacker isn't limited to logging in. They can bypass authentication entirely, exfiltrate sensitive data, or even run commands like drop table users and wipe out an entire table permanently. Here is a real example. Headland payment system. Attackers exploited an SQL injection vulnerability and gained access to their network. The result of this attack, over 130 million card records compromised, one of the largest payment card breaches in history, millions of dollars in fine, legal fees, remediation, and a hit to the customer trust they've never fully recovered from. One injection point, that was all it took for attackers to exploit this vulnerability. Here is your introduction to SQL injection, what it is, how it works, and why it matters. In the next video, we are going hands-on. We'll be solving real SQL injection lab straight from PortSwigger, step by step, real lab, real attack, real skills. If you don't want to miss it, like this video, subscribe, and share it with someone trying to break into cybersecurity too. See you in the labs.